When electromagnetic radiation interacts with matter, that radiation can be changed, or it can be emitted, or it can be absorbed in some way. This is a really important phenomenon in chemistry because we can't see atoms and molecules with our eyes. In fact, when you see on TV a scientist, they'll always have a lab coat, they'll have some safety glasses, and regardless of what kind of scientist is being portrayed, they'll always have a microscope. And when they want to tell you something about an atom or a molecule, they look through their microscope and they say, oh yeah, well that molecule's blue. That is just crazy. We can't see, there's no optical microscope that can resolve atoms and molecules. What we do is we have radiation of various wavelengths interact with atoms and molecules, and we deduce things about the molecules based on how those atoms and molecules interact with the radiation. So when radiation hits a molecule or atom or any kind of matter, many things can happen. It can be absorbed, radiation can be emitted by excited atoms, the radiation can change from high frequency to low frequency radiation, there can be a reflection process, all kinds of different things that help us understand the matter. So let's talk about absorption and emission. It can happen in many different ways. You can have a continuous absorption, so you can have a continuous absorption of many wavelengths, so a band of wavelengths, different colors hitting you all at once. So for instance, when we see white light, that's all the colors mixed together coming at us. Or we could see a bluish red or yellowish orange, several different wavelengths coming at us at once. Or several different wavelengths could be absorbed at once. So absorption and emission happen in continuous, broad swaths of radiation. And this is actually why you perceive color. When white light, a combination of all the colors, hits an object, some of those colors can be absorbed. The colors that aren't absorbed pass through or are reflected back and hit your eyeballs. And the wavelengths that hit your eyeballs can be either red or blue or green. For instance, this screen looks blue because wavelengths of white light are hitting it, but only the blues are coming back and hitting your eyeballs. Now, absorption and emission can also be discrete or line-based. That is, specific wavelengths are absorbed. So you could broadcast or have a lot of radiation hitting an object in a broad band, but only certain wavelengths are absorbed and removed from the spectrum. That's how that would look. Now, you could also have that in emission. You could have only certain wavelengths emitted from an excited atom or molecule or excited matter. Again, this would help you perceive color. If a blue and a green and a yellow wavelength were emitted from an object, that object would appear greenish blue. So we can actually look at absorption and emission from atoms, and I can show you a continuous emission spectrum. It's actually several lines being emitted at once from atoms. So let's look at that. I'll put on my safety glasses so we can do an experiment safely here on the desktop, and I'm going to bring in a series of tubes filled with gas. Now there's various different gases here, and I can excite these gases with an electric current, and then they'll emit electromagnetic radiation back to you in the visible region so you can see it. And there'll actually be some that aren't in the visible region, but we can't see them, so it doesn't matter. What I'm going to do, I'll take an electric current here, a little stimulator, and stimulate these atoms of gas, and you should see light, visible radiation coming out of the tubes. So there it is. Stimulated emission from excited gases in the visible range. That's a really interesting experiment, and it shows when a line spectrum is emitted, and there's several lines at once, you'll see kind of a bluish green or a purplish color. Let's look at absorption. Here I have some colored solutions. And why are these solutions colored? Well, white light is hitting them. And when the white light hits them, several wavelengths are absorbed, other wavelengths pass directly through and hit you in the eyeball. So red wavelengths pass through and hit you in the eyeball for this solution, and blue wavelengths, other colors absorbed, but blue passes through and hits you in the eyeballs. So we're saying all colors but red are absorbed by this. Can I prove that in a different way? Well, here's a red pen laser. If I shine this red pen laser onto my hand, I think you can see it there. Now, what I'm going to do is I'm going to shine this red pen laser through the red solution, and I'm telling you, and I think you probably agree with me, that the red should pass right through because this solution does not absorb red. Red's hitting your eyeballs now. So this red pen laser now passing through the solution still hits my hand. But I told you this blue solution, it must be absorbing reds or you'd be seeing some red. So I should be able to take my red pen laser, here it is just on my hand again, and pass it through this blue solution and have the red pen laser absorbed. So let's do that. Here it is hitting just my hand, and I'm going to move back till I go through the solution, and you can see the red is now absorbed by that blue solution. That's a beautiful demonstration of a discrete, a single wavelength, a line absorption by a blue solution. That's how colors work. Absorption and emission we're going to talk about a lot in this course because they help us understand matter.